Great, great. It's yeah, bright enough, even though it's not so bright out there today. Hopefully it should get brighter. Anyway, how are you feeling? This is week 3, and a bunch of Jose, are you in a car? You can't look at this. You can't look at the screen.
Yeah, I'm driving to class right now because I have class right after yours. So there's just a lot of traffic right now.
Okay, all right. You can switch off this, screen and listen
I'll
to
probably
us.
be there in like 15 minutes, so I'll turn it on in about that time frame. Sorry about that.
No worries, no worries. Okay. Okay, and the rest of you should feel free to switch on your cameras, and then we can get started as soon as you guys are ready. So yeah, I see this incredible level of activity in the forums, and all of you helping each other, which is like a dream for instructors. So there is nothing, I can tell you, right? There is nothing more pleasurable to any teacher anywhere in the world than to see students helping each other. Okay, and I can also tell you there is nothing more annoying or painful for a teacher to watch than students fighting amongst each other. Not fighting like this, but basically surreptitious fighting, as it were, right? Because because I've seen this. I've taught so many classes now. I've seen it when students really don't help each other, but they pretend to help, and they're basically trying to get little bits of information that they don't share so they can get an edge up. I don't see any of that unhealthy activity. And people are free, and I can see people are comfortable and free to ask questions, no matter how simple or no matter how difficult. And then other people, just don't hesitate at all to jump in and say, hey, this is how you do it. Okay, that being said, I see, because I see everything you guys do, I see some of you have progressed along to quest number 6 already. So I know who you are, every one of you. I'd like to make a small request, okay, so take a pause, okay, because I think you'll have plenty of time to do the last 3 quests, 6, 7, 8, 9, 4 quests after the midterm. Okay, at the pace you've been doing things, you will have plenty of time to do those quests. So at this time, you don't have to take a break from the later quests. You can read it up and try it out on the side when you have time and all, but use the time to essentially just scour the forums, interact with your classmates on Discord or Slack, or even ideally on Reddit. Ask people what they're stuck on, help them out. Like yesterday, I think was it Mike or Juan, arranged a phone call with Jose, I think, and saying, hey, let's do a call later on today, and then I can help you with some of the code. That's the kind of thing, right? Because no student ever, right, that I've taught has ever reached success beyond my course, right? I'm not even talking about just my course, just by being a loner. Okay, the only way to achieve great success is to pull other people with you, because there are going to be places where you're stuck, and all you need in the places where you're stuck, whether in class or in life, is just a little bit of a nudge from other people behind you to just get past that. Okay, and when you're past that, you'll be on cool and flowing, and then some other place when someone else is stuck, you can push them along too. However, if you don't have people behind you to push you, you'll spend a lot of time being stuck, and that basically tends to drain energy. Okay, it's not just wasting time. Anytime you spend more than a certain amount of time on a problem, you become less and less hopeful, and that hopelessness is what makes people give up. Okay, and so I want to appreciate that everything you're doing, and it's great for me to watch. Okay, and some quarters I used to go to Reddit and say, oh, it's going to be nothing there, it's going to be boring. Okay, and I look in, no updates, nothing to read. Okay, and say, okay, let me watch the news or something like that. But then now, every time I go to Reddit, there's always a whole bunch of new posts to see, right? And people are asking and interesting questions. Absolutely fantastic. Okay, so keep that up. And with this kind of attitude, you will all easily, effortlessly, well, I shouldn't say effortlessly, there will be effort, but certainly it'll be easy effort, and worthwhile and productive effort that you can feel proud of, you will actually go all the way to CS2B and CS2C. And once you're done with CS2C, you will never ever for the rest of your life be afraid of any other course, in whether it's data science or data engineering or machine learning, even a graduate course. You will never ever be afraid of a course that involves programming, because in my experience, what happens is that when you go to grad courses and so on, and you tackle a hard topic, like today we're going to discuss kernel functions, okay, something like that, kernel functions and how to implement them. And it's a hard topic, because you have to take something and project it into high dimensional space, and there's going to be enormous number of coefficients, infinite coefficients, and you got to estimate these values and so on, and you got to write a program to do that. And now already people who don't have the basic mechanics of computer science nailed in, they will balk at that and say, well, there's no way I can learn that. If I can't figure out how to live in 3 dimensions, how am I going to figure out how to live in infinite dimensions, right? So this kind of thing has got to be like totally super solid. When this is solid, then you can say, well, I already know how to do this. All I need to do is basically take this and apply that in there, because it's the application. Like I said, once you're comfortable with arithmetic in base 10, well, you know how to add numbers and subtract numbers, and it's exactly the same, right? Now, after having data representation, exactly the same technique works in binary, in 2 numbers. Exactly the same technique works in, octal, hexadecimal, even base 27, right? Exactly the same technique works. So like that, once you were comfortable with the basic mechanics, you'll see that, all right, now that I've got this working, I can apply the same thing in an infinite number of dimensions. Although I cannot perceive the infinite number of dimensions, the same techniques will work there. So I'll just take these techniques and let them loose in that forest with an infinite number of coefficients, and have the algorithm handle that and come back to me when it's got a result. Okay, that's really what happens, right? If you look at support vector machines, for example, right? You got to discover a plane, right? It's not really the 3-dimensional plane. It is a surface that basically divides 2 different things together, right? On this side of the plane, everything is positive examples. This side of the plane, everything is negative examples. So you want to try and infer where is this plane, so that I can describe this plane and say, give me a random example. I'll see which side of the plane that goes on, right? If it falls on this side, that's not going to happen. If it falls on this side, that's going to happen. Okay, so essentially, right? And that's kernel functions equip you for that. But in order to implement that, you need to have a solid backing in data structures and these algorithms. This is what we're trying to do. 2A and 2B, like I said before, is just the mechanics. 2C will start encountering problems that say, all right, now that you have all the tools at your disposal, let's take a look at some problems and see if you can take those tools and solve these problems. Okay, that is where the real excitement is. And you're all building up to that by basically learning how to use these tools. So that's absolutely fantastic. All right, thank you. So today, what I wanted to do was, usually I do branching statements first and then cover looping. But I thought, let's do looping first and then do branching. So maybe we'll do both today. So who knows? Otherwise, certainly on Thursday, we'll cover branching statements for sure. Today for looping, I was thinking of a problem. Actually, yesterday I was thinking of a problem, and I actually came up with 2 interesting things that we could try. I haven't actually implemented it yet, so I don't know if it's going to look good. But in my mind, it kind of looks pretty cool. All right, I think I described this to you before. This is basically standing on the edge of a cliff and throwing a stone, right? Or firing a bullet horizontally, perfectly horizontally, right? Now, if you look at it from outside, the path that bullet is going to take is not going to be like that, right? From far away, it's going to be, because the gravity of the earth is going to pull it down. Yes? Okay, so the path of the bullet is going to be like that. Yeah? Okay, now that, does anyone know what the shape is? What geometric shape that is?
Would that have to be an arc or?
Sorry, go ahead. Speak. Oh, actually, I need to connect you to. Geez, my AirPods are over there. Let's see if Alexa works. Okay. Last time we tried Alexa, it was there was a lag, and that was kind of weird to me. Hey, Alexa, connect to my Mac. So hang on just a sec. Alexa, connect to my Mac.
Searching. Now connected to McCann and Foothill.
All right.
545.
All right.
Playing
So,
from McCann and Foothill. 545.
okay. All right. Can someone say something?
Is it
Great.
working?
Thank you, Tim. All right. So this is what we'll do. So we can try and write a simple program that will ask the user for what is the speed with which you're firing the bullet. Okay. And then they'll say, oh, all right, I'm going to fire the bullet at 200 miles per second, or to 200 meters per second, or something like that. And then you're going to take that and you're going to say, now I'm going to print a bunch of lines. Okay, I'm just going to print a lot of lines. One under in a loop, you're going to print a lot of lines. And well, think this through in your head with me, because I haven't thought it through completely. Okay, and tell me if it kind of sounds sensible. Okay, so you're going to print a lot of lines, and on these lines we'll print a little star or a star, asterisk or something like that, that shows the position of the bullet at that time. So that the first line is going to show the bullet, let's say 1 second after. The second line will show the bullets in 2 seconds after, and so on and so forth. And then so the lines, the position of the star as the page scrolls down it will probably look like this. I don't know. That's what I think it's going to look like, and I'm pretty sure if it doesn't look like that, we can fiddle with the numbers and how fast the bullet is moving and all, and we can get it to look like that. That's one of the ideas that I had. The other idea I had was if you're given a string, okay, a character string, like hello, my name is Kiki, or something like that. Okay, some string, a letter, a series of letters. You want to take that string and flip it. Okay, so that it reads from right to left instead of left to right. Yeah, so it's like big endian and little endian notation in data representation. It's that I made it a small point about big endian and little endian in the data representation module 0. And you should read it, because it's interesting history in computer science. Because originally, when numbers were stored and the people were manufacturing these chips, the Intel and Motorola and all these people, AMD wasn't there at that time. So they decided, all right, I'm going to store the bits in my number. A number, let's say, has 16 bits, right? 2-byte number. Okay, 16 bits to store an integer. They said, I'm going to store the smallest number on this side, and then the largest number on this side. In other words, they're saying, if I had a number like 95, they say, I'm going to store the number as 59. You read the number from this side. Okay, and the other manufacturer said, no, I'm going to store the number this way. So 95 is written 95. Well, it's basically just hardware decisions. And I don't think there is any computational efficiency doing it one way versus the other. I can't think of one. Okay, so you can Google and find out if there is any reason other than a business reason, right? So I can think of a business reason. A business reason might be, I'm going to do it this way so that to make sure that Intel's programs written for Intel don't work on my machine, right? Therefore, if someone wants to write a program, they got to buy my hardware. Right, so I can think of 101 business reasons for doing that, but I can't think of a technical reason why people would do that. But yet, we're stuck with that for history. And so there are two different ways in which numbers are stored. One is called the big endian way, and the other one is called the little endian way. Right? It's Indian, not Indian. It's endian, and it stands for END. Right? Because it's the end. Which end of the byte pair is the least significant bit? And which end of the byte pair is the most significant, right? So big endian and little endian, and the name actually comes from Gulliver's Travels. Jonathan Swift, he wrote this book in Victorian England, and where these people, Brobdingnagians or something like that, and Lilliputians, right? These two people, I don't know, it's somewhere, right? They have a war. Right, war with each other. They're fighting, and they're just fighting, right? And then Gulliver says, "Why the hell are you guys fighting? You're basically the same people, right? Why are you fighting with each other?" And they say, "Well, no, we're not the same people, because we believe that eggs should be broken on the big end, right? And those guys, sacrilege, blasphemy. They're breaking the egg on the little end. Okay, so we can't allow them to live, right? They have to believe the same thing as us. Otherwise, we're doomed to die." And so that's the reason for their war. And like in real life too, right? That's how most of these wars are in fact happening in the real world, I think. So and so that story became the background for the computer scientists choosing, well, we have two different ways of storing integers. We'll call this one the big endian way, and that's a little endian way. So there's two different ways like that. So we're going to take a string, right? And I was thinking, we're given a string, and we have to write a little program that's going to take the string and flip all the characters over, and so that you get returned a string in which everything is in the other direction. Now there's a whole bunch of interesting ways you can do that and tackle that problem, and if we do that, maybe we'll do both problems today, right? But if we do the second problem, I think we may have scope to, there's a lot of things we can do. We can say, well, all right, I've given a string, I can manufacture a brand new string, which is the reverse of this, and return that. Okay, that's easy. The other one is, well, if I didn't have to manufacture a new string, I want to take that string and change it in place, meaning you can create a new string. Given the string, that string itself has to be changed, right? So you can't make a new string and then assign the string to the old one, okay? The stuff that you're given, you got to change that in place. That's called an in-place algorithm, okay? In-place algorithms are hugely valuable in computer science, okay? Hugely. And even in 2C, I've had 2C students say, well, in place versus not in place, not a big difference, okay? We should do whatever. No, that's not true at all, right? In-place algorithms are hugely valuable. And in fact, if you look at some of the popular sorting techniques, like quicksort, okay, it is popular only because it is an in-place algorithm. If it was not an in-place algorithm, there's so many other algorithms you can do. Merge sort, for example, right, is provably more efficient if it's not in place. But we still use quicksort because it's in place. And why is it? Because when you use an in-place algorithm, you're telling the algorithm, I want to do this, I want you to do this, but I can't give you any more space to operate. You got to do this inside the small room that you have been allocated, right? And so what can you do? If you don't have any space, you got to operate within the space that's been given. So you got to, shuffle things around and make sure, remember, and so those kinds of algorithms are called in-place algorithms, really, really powerful, sometimes ingenious, and you cannot see how they work just by looking at it and saying, okay, I got it. You got to actually think through it very carefully, and you say, wow, that is how it works. And sometimes even simple algorithms like that, well, not simple, things that do it, complete the task, we look at it and we can't see how it works. And after a while, it just clicks like that and say, wow. And that is the epiphany, right? And you say, well, that is how it works. Nobody can tell by looking at it, it works, but because they can't see this tiny minuscule detail that you'll only realize if you go right down into the code and look into the little bits. You can see, well, that little statement is what's making the whole thing work. Okay, from here you can say, well, it's just magic. It works, but you don't have a reason for it. So we can try and do the flip in place. And I'll show you how to do that. It's actually very simple with this flip. And the other thing we can do is we can carry this on to say, to check if a sentence is a palindrome. Anybody know what a palindrome is? Yeah. So someone tell us, someone share with the rest of the class.
Where you say it the same way backwards that you say it forwards?
Yeah, actually, no, not say it, write it, because I don't know, spoken palindrome. I don't know if spoken palindromes exist, but written palindromes certainly exist. Actually, spoken palindromes exist in other languages, not in English, because English is not a phonetic language. But in certain languages where the what you speak is exactly what you write, letter for letter, then it's basically a spoken palindrome too, because reverse you get. So it's a palindrome is a sentence that if you reverse it is exactly the same sentence. Okay, can someone give me an example?
A race car.
There is a very famous example. I think right. This is that example, and someone correct me if I'm wrong. Okay, because I might have forgotten. A man, a plane, a car, Panama. Oh, something like that. Just Google, okay? So Google man, plane, Panama, palindrome, okay? You'll get the sentence. I think, right? So there is a sentence, and it ends in Panama, I think, because Panama, P-A-N-A-M-A, and you read it from that side, say A-M-A-N. Yeah. Okay, so it ends in Panama, begins with a man. and then inside, I've forgotten what it is. That's a very famous palindrome. Okay. However, it is an inferior palindrome. Okay. Inferior meaning that the spaces are kind of ignored because you got to stick in the spaces. A really high quality palindrome would be a palindrome where even the spaces are reflected, right? So one of the cool palindromes, I think, I don't even know if it was if it's a French palindrome, because I don't know how it works in French. So it must have been spoken by this English guy who conquered Napoleon or defeated Napoleon, because it is supposed to be spoken by Napoleon, some French general called Napoleon, who was defeated by some English guy. Okay, and then they sent this French general Napoleon to on exile. Right, they sent him to an island called Elba, right, somewhere near France. It's an Elba. It's an island. And on that island, Napoleon died. Okay, probably due to, they say it's due to some arsenic poisoning or something like that, but somehow he died. And so, but it is said that he made a remark after he went to Elba, saying, "Able was I ere I saw Elba." In ere, E-R-E. Okay, that is a poetic form of the word before. Before is not palindromic, but ere, E-R-E, means before. So he said, "Able was I ere I saw Elba," meaning I was able before I went to Elba. After I went to Elba, I was basically screwed, right? So he said, "Able was I ere I saw Elba," and that is exactly the same. Even if you flip it over, including the spaces, because everything just reflects every single word. So we can find out if words are palindromes with us. So that's an interesting thing you can try. The other thing we can try is this is a challenging project, and I'm going to leave it in your hands. Is to flip a sentence back. Reflect the sentence. However, not character for character. It should be reflected word for word. Okay. So in fact, the words are not flipped. The words are okay. Right, but the words, this word goes here and that word goes here, right? And so the words are reflected, but the words themselves are readable, proper English words, right? They're not reflected. So that is that kind. It's not a palindrome anyway, right? So you're just reflecting the words. So reverse a sentence just in the words alone, not in. And that's an interesting problem, isn't it? It's an interesting problem which is going to require some thinking outside the box. So I will actually give you extra credit. Okay, anyone who can solve that problem and share. You don't have to share the exact code, but you can say share in the Reddit saying, "Well, I was thinking about this problem and I have this interesting solution. It might work. It doesn't have to be C++." And you can actually say, I have this idea. Is this going to work? And someone else could say, "Well, well, it may work, but there's a problem." Okay, and then you can together, all of you, try and figure out, hey, we can fix that problem and have it to work. You'll actually come up with an algorithm that can reflect a sentence word-wise. And I bet that this could potentially be an interview problem. Okay, I'm sure if you go to Google and say interview problems involving palindromes or word reflection strings, I'm sure you'll find this. Okay, but it's an interesting problem, right? Interesting problem. So we can try all of that. That's one of the things we can try. But first, I want to do this because this is something I tried to do a very long time when I was your age, or even younger than you, I think. We didn't have computers around everywhere. So one of my relatives was working in a company where they had lots of computers and there were data entry people, our programmers in a program called COBOL, a programming language COBOL, right? I didn't know COBOL, but I was, they said, we'll give you a terminal. You can go and sit and play with the computer as much as you want. So I used to go there during my summer break and basically sit there. It was an air-conditioned room, and back in India, it was really hot. So I used to go for the air conditioning first, sit in the room, and drink coffee and play with the computer. But eventually I got hooked and said, I started going not for the air conditioning, but actually for the coding and opportunities to code. So I tried to do this in a language called BASIC, and it actually worked. It worked, and I was very pleased with myself for having done that. And we could try that. We could try that here. And I would like to see it happen in C++ at some point. And the reason is and the other reason is we never did. This is an idea of this quarter. Okay, I don't think we've tried this in any previous quarter. So I think it'll be really cool if we try that today. So if you guys are okay with this, we can actually start coding. And anyone who wants to code today, ideally someone who hasn't had a chance? Everybody, Shadi, you want to go? You want to go today?
Volunteer, yeah.
Fantastic, fantastic. Thank you. I love it when when people actually volunteer and say, I want to code. I want to. Last class, Jaden said, can I get a chance to code? Okay, and those are the things I love to hear, because people coming forth and saying, I want to try this. Okay, so that makes my day. Thank you, Shadi. Okay, so at any point in time, you're going to be using VS Code, I expect, because you were okay. Great, that's great. And also, if you have time, Shadi, I know you may be doing other things and you have a life and all. If you can produce a small video at some point, okay, of installing VS Code, and also take it all the way through to dropping Hello World, right? Because it doesn't matter if you share, even people see the source code for Hello World, right? It's a very simple first quest. You can write it, drop it, again, and then if it's a small capsule like that, basically just pin it on our forum and say, hey, every student, freshman who comes in here, this is how you do it. Okay, watch this video, and I think that'll be really cool.
Okay.
Thank you. Right, anytime you're free, just feel free to take the screen. And hey, Musa, where are you? Are you in a car too?
Yeah.
Oh, you're in a passenger seat, I expect, right? So because it's,
Yeah.
you've got a laptop or phone?
I'm on my phone.
I see. Okay. Are you going to be at Foothill anytime soon?
I'm actually going to an appointment right now.
Oh, I see. Okay. All right. Just listen to class today and watch the recording later.
Okay.
Yeah. All right. Cool. All right. So let's say we create a project. We'll create a project, a new project, and we can call it. This is a new. Yeah. Let's create a new. I think it's a new folder in VS Code. We'll just say new folder. We'll call it projectile. I think it's the word that is most common is projectile. And even in physics, when we learn this, we learn, and I think this is a whole chapter called projectile motion, right? And projectile motion is basically just charting the points on a parabola. A parabola, a standard parabola. In fact, most of the time it's simpler, because the equation for a standard parabola, if you remember from your math, is ax squared plus bx plus c equals some constant, right? Ax plus equals 0, right? So, but we'll forget all of that, and we'll just say this is going to be a parabola. It's going to be a very simple parabola where a constant term is 0 and so on and so forth, and the coefficient is a is 1, and so it's going to be a simple parabola. Okay, so so let's call it let's say what do we call the main file? We'll just call it main.cpp, because we'll call it main.cpp. All right. Let's go ahead and edit main.cpp and put a comment at the top saying it's code for today's class, and today is I think 19th of April, April 19th. What time is it now? Let's make sure we have a lot of time. Yeah, we have a lot of time. Okay, great. Right. All right. And then on the next line, we'll say what we're going to do in this file. So we'll say we're going to try and print the position of a bullet fired horizontally from the edge of a cliff.
Position of the bullet.
Of a bullet, right? Not the bullet, a bullet. And then position is you're missing an O. Bullet.
I should go back.
We're going to try and print the position of a bullet shot horizontally from the edge of a cliff. And you can put that on the next line, because I think it's 80 columns. Maybe not. No, that's shot horizontally from the edge of a cliff. Hope this works, okay? Because if it does, it'll look nice. And then it will also give us a chance to understand looping constructs and things like that. Okay. All right. So let's go into our main. Yeah. All right. So we're going to do this. Write it like a real program, right? So let's do our main first, where we're going to say we'll fill in with comments saying what different chunks are going to do, because the parts under the comments are going to be pretty straightforward and you can fill in. And if you don't, I will come in and fill it in for you, right? So say int main, open, close, int main, open, close, and then space, curly brace. Get rid of the space on this side of the main so that it, great. Okay. So int main, and in your int main on the first line, you say put a comment there, indent in and put a comment, indent in 4 spaces and indent in, and put a comment saying print a prompt to ask the user for the horizontal initial velocity, initial speed. Let's just speed, horizontal speed, initial speed, horizontal initial. Yeah, it should be initial horizontal speed, but doesn't matter. Okay, yeah, that's fine. That's enough, right? So on the next line, we can say, well, yeah, few lines, and you can put a to do there. You can put a to do right under that, right? In comments, you say to do right under the print, the first comment, right under the first comment, and say to do, because that's what we're going to do. Yeah.
Mhm.
And here, notice a really cool thing about to do, right? When you hit to do, why is it underlined? Oh, okay. Why it didn't do that? Huh. All right. So some IDEs, I think I know Eclipse does that for sure. Maybe does Xcode do that? I don't know. Right? If you have a to do in your code like that, Eclipse will automatically put a little red dot, maybe not a red dot, blue dot or green dot in the margin, so that when you're looking at a huge file, and there are places where there are stubs saying this needs to be done, to do. You don't have to go scouring through the file to find out where they are. You just look at the position of the dot. And even better, they will also flag files that say, this file has got at least one to do in there. So if you have a large project working with, I don't know, 50 other people on a big project, and many of these files have to do items, the project is not ready for release to the public yet. So because you can look at the file in the IDE, and the files will be marked. Okay, this file has some to-dos and so on. So it's very easy for programmers and their teammates to go in and patch it up, and not patch it up, fill in all the holes so that the entire program is done. Right. So I don't know why that's not happening here, but that's fine. So now we need one more comment there. That's the second thing you got to do. A blank line. Yeah. Now you say read in the initial velocity. Right. Read in the initial velocity or initial speed from CN, from the user via CN, from the user via CN. CIN. That's a console input. Yeah. Does everybody know how to do that? Oh, it's all lowercase, right? Cout is sending stuff to the screen. CN gets in from the keyboard.
Oh, CN.
That's
Oh, sorry.
Yeah, now it rings a bell. Okay.
Okay.
Yeah, okay. All right. Okay. Good. Now the third thing, third line, are those the only parameters we need? Yeah, I think those are the only parameters we need. Okay. The third line is going to be call a function. To do. Another to do there. Another to do.
Okay.
No, to do. Just say to do there, because that's another thing that you got to do. Right? Yeah, blank lines. Now we can say call a function. Call a function and pass it this speed and have it print out the bullet's trajectory with asterisks. You can go to the next line now.
Bullet asterisk.
Yeah, after the word the, you can break the line. Yeah, and then comment. Yeah, bullets trajectory. Bullets trajectory. Bullet apostrophe s trajectory. Is everybody okay with this so far? That's what we're going to try to do. Right now, I'm going to reduce the size of this this panel so I can see more of you. That means I need to switch glasses also. Right. So just give me 1 second. Okay, I can certainly see more of you now. Okay, what happened? Oh, that's a different project. Great. Okay, now, yeah, that's much better. All right. All right. So this is what we're going to do, and then just before the curly brace, say return 0. All right, just before the curly brace, that's our standard, right? Return 0, indented in, and then you don't need a blank line after that. Okay. Also, but after line 15, do a to do just like the other one. Well, actually, let's not do a to do. We're gonna say we'll just call our function right there. Okay. So right there under hit enter, and you can actually call our function right there. You can go to the previous line too, because it's going to be, this is what we're doing now. Yeah. But you say plot underscore bullet position. Plot underscore bullet underscore position,
Plot?
That's the name of the function we are going to write. Okay, we are
Okay.
going to write that function. Plot underscore bullet underscore positions. Okay, and then open parentheses, and then we're going to pass it a variable called speed. Okay, speed, S-P-E-E-D. Right, that's it. And put a semicolon at the very end. Now we're using a variable called speed, but where does it come from? So let's go and define that variable. Go to the first line of main, line 6, and hit enter. Hit enter, and you say int space speed, right? Int space speed, and put a space there. Okay, semicolon and enter. Okay, so what means now? That means on line 13, we can change the comment and make the comment even more specific. We say via cin into speed. Okay, now we're going to read from cin into speed. Now everybody knows how to do that. I'm pretty sure, right? It's just one line, cin right shift into speed. Yes. Okay, so I'm not going to spell it out anymore. Okay, good. So now we've got this variable called speed. Okay, and we've got the function which we're going to write. We haven't written yet. Okay, and we're going to say to and that's it. We can get rid of the blank lines. Line, leave just one blank line above return, and everything else is right there. Okay, yeah, there you go. Right, now let's go above main now, and we're going to define our function. Okay, we're going to define our function, and what this function is going to do is basically just plot the value. Right, it's going to plot the positions of the bullet, and like here, and so on. It's going to do a lot of couts. It's not going to return anything. Right now, I can't think of anything that you're going to return. So we'll just say void. It's not going to return anything. It's going to do stuff, but it's not going to return anything. Right? Someone asked a question about, in the question, I think Xiangwen, where is she? Right, there you are. Right? Xiangwen answered the question where, return value and something about return values. Okay. So a function, yeah, int, summing ints and so on. So here we're going to have a void function. We say void space plot bullet position. And it's going to take one parameter, which is going to be speed. Yeah, so we just say int speed right there. Int speed.
Int speed.
Or let's call it int. Yeah, we'll just call it speed. Okay. No, call it int v for velocity. Okay, int v for velocity. The reason I didn't say speed and I wanted to say velocity v is because we're going to be using this variable in expressions, and then if there's more than one place where is on the same line, it'll take up more typing and more room on the line. So I say, one letter means it's easier for us to visualize the equation, right? Because in math, that's how we do it, right? We say single letter for variables. So it's easier this way. All right. So is v for velocity.
What's up?
The name, like you have void bullet position, and then down there you have bullet position.
Thanks for pointing that out.
Oh yes, thank you. All right, that's great. Okay. All right, so here's what we're going to do. This function, let's see what we want to do. Let's put a comment above the function, okay? Let's put a comment above the function. Yeah, there, we'll say, we will, so each second, okay? So let's say we calculate the position of the bullet every 10th of a second. I think it's every 10th. So let's say we fire it 100. Let's say we fire the bullet at 100 meters per second. Okay, 100 meters per second. That means it'll cover 1 meter horizontally every 0.01 seconds, right? 1/100th of a second, it covers one meter. So let's say we're going to plot the position of the bullet every 100th of a second, every 100th of a second. Yeah, of a second, every 100th of a second, by using spaces, by using leading spaces to mark, using leading spaces to offset the bullet position, and you can say star or something like that, right? You can go to the next line. Every time is a good habit to, yeah, that's right. So first time you type the top, we in any IDE and the font size and all, we try and get an intuition about where approximately 80 columns is. So that's the only time we have to look at the column number and so on. And then after you see that, then we basically in our mind say we don't have to keep count of the column numbers. Every time it's kind of like that, we're going to go to the next line. In some IDEs, I'm pretty sure it's possible even in Visual VS Code, you can actually get the IDE to show you a thin gray line at 80 columns. Okay, Eclipse, Xcode, so that people know when they're typing. They know when they're close to the gray line, go to the next line. So I don't know how you can get it in VS Code. You can find out and let other students know if necessary. Okay, now offset the bullet position from the beginning of the line. And in fact, after bullet position, you can say star, because that indicates also that we're going to use the star asterisk, star in parentheses. Yeah, like that. Yeah, space after the position, because otherwise it looks like a function, right? Function call. Yeah, from the beginning of the line, from the beginning of the line. 2 N's for N and ING. Okay. Okay, great. Now that's what we're going to do in this function. Is everybody okay with this so far? And I think this works. Okay. I think it'll work because I haven't tried it. So if you think it's not going to work, propose changes right away so that we can find out before we run it and say, hey, it doesn't work. Let's try and fiddle with it. And so I think this should work. Okay. So now let's say how long? Let's say 100. Let's say we just plot it for 2 seconds. Okay. We'll just plot it for 2 seconds, which means that we'll plot for 2 seconds. We'll plot the bullet 2 seconds, meaning that we need 200 columns, right? 2 seconds. For each second, you'll get 100 columns. Yes, because if you're going to plot it every 100th of a second, you're going to get, one bullet here and the next line here. So you're going to get 100 columns in 1 second. So if you plot it for 2 seconds, we'll get 200 columns, which I think should be, let's say 1.5 seconds. Okay, so we're going to say from now we're going to do what is called a loop. Okay, this is called a loop and is one of the basic and easiest. This is one of the easiest ways in to do looping. There's many different ways of doing looping, and I'm not going to go into all of the different ways because I know, right? In the past, and also other instructors, right? They spend a lot of time teaching students 5 different ways of looping. Okay, there's a for loop, there's a while loop, there's a do while loop, there's a recursive loop. There's all these different kinds of looping, all of it, right? And in my experience, I tried that, and all it helped was it never helped. All it did was basically overwhelm the students. Okay, and I said I'm never going to learn looping because there's 500 different ways to do this, right? How can I? And then in the exam, you got to say, oh, I got to remember this many things. So you're not going to learn the concept. You're just going to learn the syntactic structure, right? It's like, oh, I can loop in 5 different ways, right? But then I asked them, okay, now you know how you say how to loop in 5 different ways. Now here's a problem that involves looping, right? Do it. They can't do it, right? I have seen students like that. They say they know how to loop in 5 different ways, but they cannot use a loop. So what's the point? What's the point of saying I know different ways of doing it, but if you actually don't know how to do any of those properly? So what I'm going to do is basically just teach you one way of looping, and this is the easiest way. A for loop is actually the easiest way to loop, and as you'll see. But once you know how to loop it, right, it is exactly the same. Just like decimal to binary, all the other looping ways is exactly the same. You just have to find out. All right, now suppose I want to use a while loop. How do I do it? Now you go to the modules or a textbook and say, how do I use a while loop? Because I only learned how to do a for loop. Now you approach the while loop with the for loop in mind already. Therefore, when you're learning about while loops, you're not going in with a blank slate, saying, I don't know anything. You're not going cold. You're saying, I already know how to do it with a for loop. What I need to know is how to take that and turn that into a while loop. That way, you'll learn a while loop 5,000 times faster than if you went cold. Right? So if you know to loop already, all you're learning is another way of doing the same thing. Rather than saying, here's 5 different ways of doing it, learn them all from scratch, never works. Okay? So for loops is good. Now you can go after this class, look in the modules and try out, different ways, because everything you can do with for loops, you can do it with the other loops too. Everything you can do, essentially everything is a loop. Because if you distill everything down to machine instructions, those of you who are doing computer architecture, right? At the level of a machine, right, CPU, there's no different kind. There are no different kinds of loops. There's only one kind of loop. There's only jumps. In fact, there's no jump loop even, right? At the level of the CPU, you only have a jump instruction, which is like a go-to, right? It's go-to, which you should never use. There is this go-to statement in C++. I have seen experienced high quality programmers use go-to statements. Okay, and then in fact, if you look at Don Knuth's books, right? Don Knuth at Stanford, the fundamental algorithms, he uses go-tos in all the algorithms that he describes in his book, and those are brilliant, incredible algorithms that are not immediately obvious how they work, but he uses loops, and still the algorithms are easy to read. So what I mean by that is that go-tos do have a place, and you can use them, but in order to use go-tos in programming languages, you need lots and lots of experience. Okay, you need to have programmed at least for 10 years, I think, right? If you have programmed for 10 years, then you are qualified to use go-tos in your program, because you will know at that point, right, what a program should not be like in order to be confusing. The programs, first and foremost, should be correct, and the second most important thing is to be easy to read. Okay, well, second, yeah, maybe easy to read and efficiency come along, but it should be easy to read. And that knowing what is easy to read and what is not easy to read cannot come from a teacher to a student. Okay, I can tell you that nobody in the world can teach you this is good quality and that is not good quality, right? Even if it's an art, any art, anything else, right? Whatever you learn in this world, yes, thank you, right? So I can show you how the thing works, basic things, but then you got to figure out in your own time, putting things together, right? And trying various things and saying, did this, does it look good? Does it look good? Does it look good, right? Even kids, after a while, when they try to draw pictures, for example, right? So the parents can maybe, or the teacher can guide them and saying, well, this is how you draw a line, this is a circle, and so on and so forth. Initially, they'll say, well, I've drawn a circle. Does it look good? Look good, right? But after a while, they're going to try different things, and they've got a sense of what a circle should look like in their head, right? They're not going to go and ask their parent every time, is this a good circle? Is it going to try and do this and say, well, it doesn't look so good. Doesn't look, yes? Is that how it happens? So the instruction only covers the bottom 10% of what most people need to learn, right? 90% of everything you learn does not come from the outside. It's already inside of you, right? I know, because sometimes I teach students and they come up with some brilliant insight about something, right? During one-on-ones or something like that. And I say, all right. And initially I used to think, well, someone must have taught them this, right? Because this thing they could not have come up with by themselves. I used to think, right? And say, well, this is a really sophisticated thought. And I know, because it's been discussed in some algorithm in some research paper, right? So how did you, who taught you how to do that, right? And they say, no, I was kind of figuring it out, and that's how I tried to do this, right? And they came up with it on their own. Now, of course, students could say that even though they have not, they've got the answer from somewhere else. So, I try and find out, and most of the time, what I come out of the discussion with is that, yes, that person was speaking the truth, right? What they described to me could not have been taught by someone else, because the way they described it to me, right? That's how teachers, that's how they find out, right? The way you approach a problem is what gives out the truth, saying, is this solution genuine? Did it come from inside of them, or was it actually purchased or come from outside? And sometimes some of these complicated concepts, I shouldn't say complicated, right? Nothing is complicated. Some of these sophisticated concepts bubble out from inside the student, right? And if you're not careful, and if the teacher is not careful, they would not be able to tell the difference. And they would probably think, well, that came from outside. Someone taught it to them. Maybe their parent, their brother or sister who's working at some top software company, they told them how to do it, right? But it is possible for teachers to tease it out using just simple questions. Well, all right. Just give me 1 sec, okay? It's here for breakfast again. Well, you can see him again. Come on. All right.
Wait, there are two squirrels, Vector and Peter? There are Vector and Peter, or?
Oh, I'm sorry, I can't hear. No. Hey, okay. Raining today, so oh, he's wet. Okay, Peter moment. All right, now, so is that clear? So what I was trying to say, hey, Shadi, you had a question. Sorry.
Oh, I just thought you said Vector, and then I thought there were two squirrels, but you said Peter.
Oh yeah, Peter.
Yeah.
Okay, so I don't know where I was going with, thoughts bubbling out of the students themselves. Yeah, people can recognize that, and if you're careful with what you are creating, okay, and that's why students themselves can't tell. Many times they're coming up with these brilliant ideas, and they cannot tell that these ideas came from them. Yeah, and they think, and I think stupidly, that someone else taught them, or it came from a book, or from a module, or from professor. No, it didn't come from them. It came from themselves, because the professor only gave you the superficial aspects, right? They didn't tell you the details, the depth of the thing. And what they've done is basically stirred the water and let you do all the work. Your mind, right? That thing is going to come up with the idea when you're going on a walk, right? When you see some random phenomena happen in the world, like a bird flying, right? And say, wow, that is the arc that I was trying to model, or something like that. So these flashes happen. And many times students are not aware of these, because they just dismiss these things, because their mind is occupied with 1,000 other things, right? So something like this happen and you can't tell. But if you're really careful when you're coding, and as you're coding, you can train your mind. Just have to slow down a little bit, okay? If you're going really fast, you can't tell where your brilliant flashes are coming from. Yeah, natural, isn't it? If you're going really fast, you can't tell. But if you slow down and think through everything you're doing, you will actually see many places in your work, not just programming, many places in any line of work you're doing, where you have come up with real value. You have come, and that will also help you, right? In a job, you have to, at the end of the year, your manager is going to ask you to do there's going to be a performance review. And in the performance review, the manager is not going to say, well, this person did this, right? So they'll say, write a personal reflection and submit it, right? And then during the review, we'll look at it. And so, and I know when employees are asked to write the review of what they've done and bring it to the meeting, many of them are struggling because they don't know what they can put in there. And this is the way you can come up with really valuable stuff to put inside those documents to share with managers, by just being mindful of what you're doing. And you can be mindful of what you're doing just by slowing down and taking a breather and saying, all right, I'm going to think through these things one step at a time so that I know. So when you have these flashes, you can basically make a note of that and say, well, at the end of the year, this is something I want to basically accentuate in my review, right? And say, well, in that large project, we were doing this, and I came up with that thing, which basically improved the efficiency of that algorithm, or cut down development time by 3 hours per day, or something like that. So these are things that you learn to identify to increase your own value, because that is the worst thing that happens out there. Lots of people I see are really talented people who are not getting promoted, who are being stuck in a rut, not advancing in their career, not getting interesting, juicy projects, and all because they have not been giving themselves the luxury of doing their things more mindfully and looking at it to see where the real value was. Okay, and if you do that, you'll find that a lot of these things come out from you. Okay, so let's go on to the next line. This is what we're going to do. Is that okay? So that's what we want to do here. So we're going to do a loop and saying what we'll do is say on the first line, we're going to define a constant. Okay, const int const size t, number of let's say n positions. Okay, a number of positions, we'll just call it n positions. You can use either n positions, call it n positions. Constant size underscore t, right? Size underscore t is just a synonym for in C++ for he's back, but that's it. Okay, I think he probably hit it. Maybe it's some other squirrel. Well, let him come back later. Okay, so const size t and say n positions, right? Space n positions. Yeah, okay, that's good. Equals what do we say? We'll do 150 positions. Okay, 150 positions.
Do I need to write positions?
No, 150. I'm sorry, semicolon there. But we'll put a comment on that line. At the end of that line, there's space, and we can say 1/100th of a second. So 1 position per 100th of a second. So we'll have 150. So 1 position per 100th of a second for 1.5 seconds. Yeah, for 1.5 seconds. Okay, good. 150 for 1.5 seconds. So so it's clear that we're going to plot the position of the bullet for 150 time locations. Right? 150 positions. Just say positions.
Okay, yeah, positions.
Positions, locations, whatever. Okay, now a couple of blank lines, and then this is our loop. This is our for loop, and we're going to say for open parentheses size t, size underscore t, I equals 0 semicolon. Now the condition, right? We're going to say we're going to stick in this loop until the value of I becomes greater than some value, some condition, right? So we're going to say I less than n positions, right? I less than n positions, and put spaces around the less than sign so that it reads better.
Oh, less than, okay.
It's all operators we put space, and also we need a space between the closing parenthesis open brace on the declaration line, int v, right? No, on the declaration line. Int v,
Declaration. Oh, here?
line. No, after that, yeah, there you go.
Okay.
It looks much better this way. All right, now and then after the semicolon on line 11, you say I plus plus. Okay, and these are things that you got to Google and find out, or it's in the modules, it's in the text everywhere you look, trying to find out what I plus plus is, and it's going to be important in the midterm test in a couple of weeks. What is the difference between I plus plus and plus plus I? Because the plus plus can happen this side or that side of a variable. All that means, in this case, it doesn't make any difference, but in certain cases, I plus plus is different from plus plus I, and make a note of this. You've got to research and find out, research meaning this Google, right? Find out what's the difference between I plus plus and plus plus I, examples, right? And you'll find like a billion pages saying, yeah, here's an example, right? And you got to understand, it's very simple to understand what it is. You can also share your findings. Hey, I did some research. I mean, in the forums, you can say, I did some research to discover the difference between I plus plus and I, or n plus plus and plus plus n. And here's what I found. If I do I plus plus here, this is the output I get. But if I do plus plus I, this is the output I get. Exactly the same statements, except for the plus plus, and I see two different behaviors. Okay, therefore, this is what must be going on. So these are interesting things to share in the forums, and it'll be beneficial to everybody. Okay, so so on the next line, you've got. I see.
It says this is not identified or something like that. Yeah.
Oh, wow. Hang on. Yeah. Oh, geez. We don't even have the standard headers on the top. I completely forgot. Just go to the top. Yeah, right there, and say hash include IO stream, hash include IO stream.
Sorry.
Because in one of those files that is included from IO stream, I bet there is a hash define size t is unsigned wrong or something like that. Right? We're missing that. That's all. No semicolon at the end. And then on the next line, you can also say, hash. You can say using namespace standard. And I think also, std semicolon. Put a blank line above that. And put a space before after include, and get rid of the space before the include. So stick the hash with the hash. Yeah, there you go. Right. So and then you have two blank lines. You can get rid of those. One isn't. Yeah. Okay. Good. So now size t works. Okay. Yeah. Is that okay? Does everybody understand what we're doing? So I just don't want me and Shadi alone to be marching forward. Okay. So great. Thank you, Jose and Kate. All right, now inside of the for loop. Yeah, sure, go ahead.
Quick question. When we want to define a constant and we want multiple things to define as a constant, do we not need can we define as many things as we want?
Yes, on the same line. Are you asking on the same line?
Yeah, on the same line and with a space.
Yeah, okay. Let's do one more and we can delete it, right? After the 150, put a comma there. After the 150, put a comma. The initialization has got to be stuck with the variable, right? Because if you didn't have equals 150, you can just put a comma right after the variable, but we had, right? So you can say n positions equal 150 and say max is a max, right? Max equals 5 million, I don't know. Whatever, something like that. Okay, so you can define as many as you want. Or if you don't want to assign an initial value, you can say just say max and say semicolon there. But that way, the compiler will complain. If you put a, if you put that, the compiler should complain. Okay, let me see if the compiler. Yeah, there you go. It does complain. Why is it not underlined? It's supposed to be underlined. Oh, you got a warning. Yeah.
Oh, yeah.
It's a warning because it's a warning and not an error because your program will compile and work, but the compiler says, hey, I'm warning you because you have a constant and you've not assigned a value to it. Why is that a problem? Because a constant, you can't change the value. Once constant means you can't change the value after that. So you got a constant here whose value you don't know because it's a random. You just say, give me some space out there, and it's a constant. You don't know what's in that space. It's constant, and which means you can't change it afterwards. So you basically got a room which is locked, and you can't look in the room. What can you do with it? You can't do anything, right? So however, that room is not going to prevent you from doing your job. So the compiler warns you, saying, well, I'm warning you, there's something wrong here. Okay, that's what the warning means. Okay, now is everybody clear on how you can define multiple constants? Exactly the same. If you want to define multiple variables, also you do the same thing, right? Int I, j, k, I, comma, j, comma, k. Yeah, just like that, you do this. All right, now here what we're going to do is when I equals 0, we'll say the bullet has traveled 0.01 seconds. When I equals 2, it has traveled 0.02 seconds, and so on. Okay, so on the first line, we're gonna put the star where the bullet would be after 0.01 seconds. On the second line, you're gonna put the star where the bullet will be after 0.02 seconds. Yes or no? This is a crucial bit. If everybody is okay with this, we actually have the whole program nailed, right? It's ready to go. But if you understand this, you're good, right? So I want everybody, every single one of you to say yes. All right, or raise your hand or say we can proceed, because that's what we want to do. Okay, well, Shadi is writing, so she's one step ahead. I want everybody else. Okay, so everybody else to say we're good, we can proceed. What we're trying to do here is we're going to take on the first line the star. The first line, the star is going to say this is where the bullet is. It's traveled 0.01 seconds. On the second line, the star is going to be slightly here, slightly to the right, because the bullet has traveled a bit more. Yes. How many spaces to put there before you put the star? That's what we're going to calculate. Yes. Now, is that? We got to get the vertical. Yeah. Okay. No, I think. Yeah. Okay. So we need to calculate the vertical half 80 squared. Let's put the equations up there. Okay. In the first comment after line 10. Comment after line 10. We want to say. See, this is what happens when I haven't solved the problem before and I'm trying to solve it through a student right here on screen. This is what happens, okay? Because I haven't taught it through completely. On the next line, we say the horizontal distance covered by the bullet is given by v times t, right? V times t. V times t. No, v times t. That's good, right? Where v is the velocity of the bullet. Yes or no? Right? And that's going to be the same because we'll assume there's no air resistance, right? So it's going to be Newton's law, right? If there's no resistance, if there's no opposing force, it's going to travel at the same speed because of inertia. Yes or no? Right? So the horizontal distance is vt. Vertical distance traveled because of acceleration. On the next line, you can say the vertical distance traveled is going to be, so what is the vertical distance? The vertical distance is half AT squared, isn't it? Half times g, this is gravitational acceleration, times t squared. Yeah, because the distance traveled vertically is vt plus half gt squared. But in our case, the vertical downward velocity is 0 to start with, so the initial velocity is 0. So the vertical distance traveled is half gt squared. Yes, half times g times t, right? Half gt squared. Is everybody okay with this? Okay, so this is what we want to do. How do we do this? So the first line, we print the horizontal, and then the second line will have to be, I think, okay, so this is what we're going to do, okay? In order to print the second line, we're going to have to travel vertically more spaces. And we'll do this, okay? So inside of the for loop, you say horizontal distance. Yeah, so say int horizontal distance or size t horizontal distance, size t space h underscore dist
Size t
space
space.
h underscore dist, right? The horizontal distance. We're going to call it h underscore dist, okay? Is it reasonable enough for people to, yeah, h dist equals?
Do you want me to write distance? Since
Yeah,
we
okay, yeah, you
given
can actually say, yeah, h distance equals v times t, right? V times t, semicolon, and we'll assume that this is going to be 0.01 seconds times 100 meters squared. Okay, right? So you'll get one there. Right. So v times, oh no, v times I. Oh, in fact, let's call it t equals 0, t less than n positions, t plus plus, I think, because then it'll all look much clearer. Instead of I, let's use a variable t.
Oh,
Right?
okay.
Even in the loop, Yeah. All right. So v times t. That's the, and then the vertical distance on the next line. You can say size underscore t v distance.
So size t v distance
Equals v. Is half times 0.5. Say 0.5. No, don't do 1/2. 1/2 is actually 0 because they're both integers, right? 1 is an integer, 2 is an integer, and so the division will happen in integer space. And integer space doesn't let you store the 0.5, so it'll discard it, so you get 0. So 1/2 is 0. So we got to say either 1/2.0, or you can just say 0.5. Right? 0.5 times. No, you can't use math notation there. Space times t space another times t. This is t squared. T squared is t times t. Yes. Okay. All right. Now blank line there. Yeah, blank line, and we want to say, put a comment there saying, put a comment. Yeah, there you go. Put a comment saying what do we want to do? So we want to skip as many rows. We want to skip as many rows. So put a comment there saying we want to skip as many rows as determined by the vertical distance. Skip as many rows as determined by the vertical distance. And print a line. Yeah, and then on the next line, you can say, yeah, on the next line, you can say, and print a line with the horizontal distance represented by spaces, followed by a star that represents the bullet. Does that make sense? I think this should work, okay? I have to admit the mental picture I had of what it'll look like is slightly different, but I think it should work. Okay, all right.
print a line with the horizontal space represented by.
Yeah, the horizontal. Yeah, I see the horizontal. The horizontal distance represented by spaces.
All right. So
Distance represented by spaces. And on the next line, you can say vertical distance represented by blank lines. Does that make sense? Yeah. All right. So that's what we're going to do. Now we know what the horizontal distance is. Then we know what the vertical distance is. So the first thing we're going to do is put a loop there that's basically going to print as many blank lines as determined by the vertical distance. Now, again, let's use the same scale for the vertical distance. So we'll say that if the vertical distance is x, right? If the vertical distance is x, can we use x? Yeah, I think so. Yeah, let's use x. Okay, so no, well, let's use y. Okay, let's use y for the vertical distance, x and y. That's much better. Okay, so if the vertical distance is y, some number, it's going to be some number. We want to print as many blank lines as needed by that. Okay, so what we'll do there is on the next line, we'll have another for loop, a nested for loop right there. Yeah, for let's say int y equals 0, for size t y equals 0, for size t, y equals 0, semicolon, y is less than v distance. Is everything clear and okay so far? Now, by the way, as we're coding, if you're running this code in your head and see potential problems, saying, well, you know, maybe that's not going to work, please let us know so that Shadi and I don't waste a lot of time writing up the entire code and then discover, oh, there's a fundamental problem. Okay, so if you can think of any problems with this code, just speak up and say, hey, you know, fix it. All right, and also put a space before the brace so that it's nicer. Opening brace. Great. Okay. Now here, all you're going to do is just say C out endo, because you know it's just going to be blank line, isn't it? C out endo.
Endo. Okay.
Oh, I'm sorry. Left shift endo. Yeah.
All right.
And then because there's only one statement in this for loop, it doesn't need to have a body. A body is basically things that are enclosed inside of curly braces, right? And typically people use curly braces to say, this is a block that needs to be executed, but treat that entire block as a single statement. Because a for loop, while loops, all of these things, if statements, they only allow for one statement. So if you need more than one statement, you got to put them in braces. Now, in this case, we only have one statement, so we can get rid of, yeah. Is that okay? Okay, so that will print, are we okay? Mind you, we have not run the code yet. So all we're doing now is running it in our head. And in our head, we're going to try and imagine what's going to happen. And so try and imagine the picture and say, this is what's going to happen. We've calculated how far the bullet would have traveled downwards. And so we're going to print that many blank lines. And then this is where the bullet has fallen. Now let's try and figure out where this bullet would be horizontally. And then we're going to print that many spaces and then the stop. Yes? Okay, that's the picture I have in my head. I don't know if it's going to work. Okay, I don't know if it's going to work,
Yeah.
but you know, the proof is in the pudding.
For the
Michael,
vertical distance, there's no gravity.
Oh, there isn't? Oh yeah, I'm so sorry. Yeah, okay, all right. So let's go. We need one more constant. All right, one more constant. Let's go to the top. After size t underscore v distance. No, sorry, I'm sorry. Yeah, there you go. Right. Next line. Oh, no, where you had it is fine. Where you had it is fine.
Okay.
Where you had it is fine. Comma there. In fact, we'll do what Shadi wanted to do then. No, after the 150. Yeah, you can say G equals. Are we doing it in meters? We're gonna have to change this. We'll say 9.81 right now. Oh, I see. We gotta say. Let's say. All right. Take the G to the next line. It's not an integer, okay? Let's, on the next line, you say, semicolon there, and then say const, double, right? We're going to use double, it's a floating point number. So we'll say double G equals 9.8, yeah? And then take the comment to the previous line because that position thing refers to that, end positions. No, next line. Yeah. All right, so is everybody okay with this so far?
Instead of put the C out end of after the for size t y loop, do you need another nested loop for the horizontal? Because you don't need just the last dot, right? You need actually a line, it's trace, right?
Yes. Thank you, Xiangwan. Right. So what she's saying is that do we need another loop? It's not a nested loop. We need another loop here to print all the spaces. What the first loop, that loop that Xiangwan is referring to, is basically just printing vertical space. No. Oh, I think it just needs to be blank lines. Oh yes. I think what we need to do is I see where you're coming from. We're just going to do two loops and they're not going to be nested loops. And I think in any case, I don't think we're going to have nested loops ever in this, but we do need to have one more loop, as Xiangwan pointed out. So now we're going to say for size t x equals 0, for size t x equals 0, x equals 0, and then x less than h distance, x plus plus,
Sorry.
Yeah, it's fine, right? On the next line, you're just going to say C out a single space, right? So C out, left shift, a space within quotes, and make it a single quote so that it's a character, and then it's cheaper to print a single character, even though it's, because if you pass that, it's going to pass, a different, it's going to call a different method. So, all right. So now after that, immediately after that, yeah, now you're going to say C out, and then stick the C out with the for statement, because that block, that block is basically printing the position of the bullet. C out, and then print a star, just like the space. You're going to print a star now. That's a bullet, and then after the star, you say endl, right? Left shift endl. Yeah. Okay, that's it. Right now, this part is going to print spaces, and then at the end of the space, it's going to print a star. That's all it's going to do. And so what we've had, what we've got is, we're just every line is going to be printed by first traveling vertically, and then traveling horizontally and printing a star. How much you travel vertically is determined by. Oh, yes. I can already see a problem with that, because we're going to fix this, and my fear is that it may slightly throw you off track and look complicated. It is not complicated. Okay, so please follow me when I say, describe what the problem is and tell me if you understand. Okay, so printing the horizontal distance every time is perfectly fine, because what we've done there is perfectly fine, because every time you're starting at the beginning and you need to go that far. Yes, that's the distance. However, what we calculated is the vertical distance starting from the top of the line, right? So starting from here, we calculate the vertical distance each time. So we've already printed a star. So the next thing, you can't go from there again, each vertical distance. That vertical distance comes from here, not from here, from the previous line you printed. Yes. So the amount of vertical distance you travel is not dependent only on the vertical distance that you calculated. It is also dependent on where you started from and how much vertical distance you've already covered. So the vertical distance traveling loop, the y loop, should not be all the way from 0 to v, but it should be from the previous vertical distance to the new vertical distance. Does that make sense? You have to visualize that, and if it's going to take you a few seconds to visualize that and understand exactly what we're trying to do, please take your time. Please discuss it if necessary. But we just need to be 100% clear on exactly what we're doing there. Is we got the vertical distance, but vertical distance is not from the previous position of the bullet, because it's already traveled here, right? The vertical distance, half VD squared, half GT squared, is from the top, the total distance traveled since the bullet was dropped. Yes? Half GT squared is the total distance traveled since the time the bullet was fired. Yes? That is the distance, the vertical distance. It is not the time, because the last time you printed it was maybe at 3 seconds later. 1 second later, you printed the star here. Okay. Now you calculate a new vertical distance, and the new vertical distance puts a star here below. But the value of a vertical distance is not this distance, but it's that distance. Yes or no?
I think it's okay, because the v distance is changing to by the time.
Sorry?
I think it's okay for this algorithm, because t is also changing. I mean, v distance is changing based on t. So every time you start from 0 to the new v distance should be fine.
Right, but the thing, and I'm glad you brought it up, Xiangwen, because this is a little thing that we have to get our mind around. Yes, what is v distance? V distance is the total distance traveled from the top of the page. Yes, that is the v distance. V distance is the total distance. Yes or no? Yes or no? Half GT squared is the total distance traveled by the bullet vertically since the time it was fired. Yes. But we've already printed a whole lot of blank lines. All these, every position we printed for the bullet has next line, right? So we've already covered some of that V distance in the previous printouts, which we'll see, right? Maybe, maybe it's a little hard for you to visualize it because you've never run this before, but once we run it the first time, you'll see exactly what I mean, okay? So what we need to do is every time you do the vertical distance loop, what we need to do is just remember before, right at the top, after the constant declarations, inside, yeah, right at the top, after const declarations at the top, line 15, enter. Right? So you say int, size t, and then the name of the variable, no, not int. The name of the variable is going to be v distance already traveled, okay? Or v distance already, yeah, let's call it v distance already traveled, okay? It's going to be a long variable name, but we're not going to use it all that often. Okay, now equals 0. We start with 0 because at the time the bullet is fired, vertical distance is traveled is 0. Yes or no? And then each time we're going to calculate the vertical distance and we're going to say that is the total vertical distance is traveled. Yes? So when you get to the place where you calculate vertical distance, right? So there you go. There you go. So size t vertical distance. Okay, on the next line, after size t vertical distance, no, on line, what is it? Line 20. Line 20, hit enter. Hit enter on line 20, right? Right. So size t, v distance to travel. V distance to travel. V underscore distance to travel. To travel equals v distance minus v distance already traveled. Okay, now you can say at the end of the big for loop, no, at the end of yeah, after you print the star, right there, yeah, enter, and you can say v distance already traveled equals v distance. Now this part is the bit that we have to get our minds around, I think, because what we've done is everybody clear with this? Well, when we run it, we can go over this again, okay? And I think it'll be clearer. Okay, that's basically, have we done everything now? Blank line, I think so. I think get rid of you got 2 blank lines there. After, yeah, 28 and after, yeah, there you go. I think that's it for the function.
You actually didn't use the v distance already traveled. You just declared it. You didn't use it in the loop, or?
Well, we did use it in the loop. See, we're using it in line
21. The v distance already traveled.
Mm-hmm.
So every time the loop runs,
or you want to switch the v distance equals v distance already traveled?
I'm happy to explain this, but I want someone else to take a stab at it if you like, right? Can someone answer Changwon's question? It's a good question, and it also is important because we just need to be 100% clear on what we're trying to do. And maybe there's a problem here. Maybe there's a real problem here, which we will uncover, right? But what we're trying to do here is every time you want to print the star, the position, we want to calculate how many lines, what the total vertical distance is from the top. How far should I travel vertically before I print the star? Now that distance tells you the total number of blank lines, a total number of lines that should be above this line, right? But you've already traveled a certain number of lines with the previous star you printed. Yes or no? So all we need to do is to travel the total vertical distance, is to travel the difference between what you've already traveled and plus, more blank lines to get to the new vertical distance. Because the vertical distance is going to increase Every step of the way, the vertical distance is going to increase, right? Because t only increases, isn't it? T only increases, goes from 0 up to, I don't know, v distance. Oh, no, no, it's 0 to 150, right? 150 centiseconds, right? Centiseconds, is it? 0.01 seconds is centiseconds, right? So t constantly increases. Yes? Therefore, the vertical distance is also going to constantly increase. It's called monotonically increasing. Monotonically means it always increases, never decreases, right? It's a technical term. Don't worry about it. You'll come across this term elsewhere. That's a monotonic function. So monotonic means it only has one tone. It's always going down or always going up. So in this case, right, t is monotonically increasing. Time is always increasing. And since the stone is not has not got a force upwards, it's only got a force downwards because of gravity, right? The distance from the place it was dropped is got to be monotonically increasing with time. As time increases, the distance from there is also going to increase. Yes or no? Yes? I know, I see Tim nodding his head. Xiangwen, but I want Xiangwen to be also in agreement because she asked a question. So I'll take Xiangwen's response as a representation of anybody else who also has the same problem. Okay, so Xiangwen, are you clear that with time, the distance of the stone or the bullet from the place where it was dropped is only going to increase? Yes? Can hear you.
Yeah, I'm good
Xiangwen.
with that. I'm good with that. I'm just saying, you are not using this v distance already traveled, this variable in your code.
I am.
You just defined it. You just defined it.
No, I am. I know. I am using it. Am I not? Maybe there's a bug, right? Let me take a look. V distance, the distance to travel is the distance already traveled subtracted from the total distance you should travel. And then at the end, I'm saying the distance traveled is now the total distance. I think it's correct.
Yeah, and then you are you supposed to use this?
Yes. So the next time around the loop, I suppose you haven't done loops before. The next time around the loop, it's going to take the new vertical distance already traveled, which has been reset on line 34. On line 34, you're changing the vertical distance already traveled. Yes?
Yeah.
On line 34, you're changing it to whatever the new distance is.
Yes.
So when you go back to the top of the loop, the next time you calculate the distance to travel, it's going to be the new vertical distance minus the distance already traveled, which you changed the last time.
Yeah, then you should use distance to travel use that variable somewhere, right? Distance to travel.
Oh, thank you. So I totally didn't see. I didn't see that at all. And see, that's why many eyes on the code sometimes helps. Okay. Where's the loop? Where's the loop? I think we're the first loop, the 27, line 27. That's what she means. Okay. Change v distance to v distance to travel. V distance to travel. There, we forgot to do that, right? Because now we've calculated the difference, and that's how much we need to travel, not the whole v distance. We just need to travel the distance that is, already traveled plus this difference. Yes. Now, is that clear? Does it answer your question, Xiangwen? All right, so she's nodding her head, but I want to make sure that everybody else is also comfortable with this, because obviously, since one student asked a question, I'm pretty sure that other people may not yet be 100% comfortable with that. But hopefully, you will be comfortable when we run it. We're going to run it right now, right? We're in our main. We're going to ask for values and run it. But even before running it, it actually helps to try and get mentally comfortable with it. Meaning, you can run the code in your head, right? If you can, so hands up if you can run the code in your head, even if it takes a few seconds, it's fine. I'll wait. Right? Run the code in your head. Imagine a bullet being fired. Okay. Imagine these things being calculated, and this thing is going to happen repeatedly in a loop, and the values change in the loop. Just run in your head and see if it works. If you're not able to picturize that in your head, it's fine, because you've not run loops before. We'll now do the main, complete the program, run it, and then we'll be able to see what happens. Is that okay? Can we do that?
Excuse me,
If everybody's okay, we can do that.
Excuse me.
Asanta, you have a question?
Yeah, line 20, we haven't at the G8. times g times t squared. Line 20.
Oh, we don't have, oh, yeah, line 20, he said line 20. Yes. Oh, that, yeah, Michael, yeah. Where was, so when we did something when Michael pointed that out, what did we do? When Michael pointed that out?
declared
We
it.
added 9.8 somewhere.
Yeah, we declared 9.8.
Oh, yeah. All right.
Isn't
So we
it?
need to add G. We need to add G, have 0.5 times G times T times T. Yeah, all right.
It should be negative as well, correct?
Unconventional way, but,
Should it be negative?
No, it's a good question. Okay, because he's saying what Michael's saying is that in physics problems, right? In physics problems, we sometimes treat G as negative, and that's for and we treat G as negative for things that are launched upwards because G is pulling it down against the direction of motion. Yes, but in this case, we're just using G as real acceleration in the direction of motion. If the acceleration is in the direction of motion, it's positive. If the acceleration is against the direction of motion, it's negative. That's why they have the braking effect. Right? So that's why we're using it as in positive form here. Does that answer your question, Mike? Everybody clear so far? Can we go ahead and implement the rest of it? Okay, great. So let's go to main now. Let's go to main, print the prompt and say, where the first to do is. Do you want me to do this or you want to take a few seconds? How about I give you like exactly 5 minutes, because no more than 5 minutes here, okay? Because when I come back, I'll just go take a bio break.
The while loop is still using the v distance, not the v distance to travel.
Let's take a look. No, it's using v distance to travel. See?
The while loop.
Where's the while loop? There's no while loop.
The second, the first nested loop.
Which line number?
Line 27.
Oh, so I equals 0. No, y equals 0. Y less than distance to travel.
Distance to travel. Am I seeing the different screen?
Refresh your page, maybe.
Oh, let me maybe.
No, it's Zoom. Does anybody else see v distance? Is there v distance to travel?
For line 21 or line
27.
27.
I see v distance to travel. I see v distance to
Oh, okay. I don't know why I'm seeing.
I was the one.
Can you just type some junk? Just type some junk somewhere, Shadi, and let's see if and Shangwan can see the junk. Can you see the junk on screen? You keep on typing, so there's some motion there. Can you see it? Shadi's typing some junk there, just punching random keys. You can't see it? I can't hear you.
Oh, I think she dropped out. Maybe she's rejoining.
No, I can see you.
I will drop out and rejoin. Probably stuck here. Okay, sorry.
Oh, I see. Well, I could hear you and all and see you, but I couldn't. All right.
I was wondering about something.
Mm-hmm.
Since v distance already traveled will equal v distance in line 34, will it get confused that in line it's after when it says v distance minus v distance already traveled there?
Oh, I see. So, so you see on line 20, line 20? Yeah, line 20, we're calculating v distance afresh. Each time in the loop, we're calculating a new v distance, right?
Right.
When you do that calculation on line 20, what does the calculation tell you? That calculation tells you the total distance traveled by the bullet since the time it was fired. That v distance, that what you calculate on line 20, tells you the total from here. That we all need to be on the same page there, right? Half gt squared. That distance, v distance that you calculate there, is the total distance traveled. We calculate that every single time you go to the loop. That loop is going to be repeated 150 times. It's going to do that loop 150 times, right? Any variables that you change there, they're going to keep the value. So you change the value of v distance to travel at the bottom, right? At the bottom of the loop on line 34, you change the value of v distance to travel, yes? Now, after that, it's going to go back to the top of the loop. But when it goes to the top of the loop, it's going to keep that value for v distance already traveled. It's not going to change the value every time.
So you have
maybe
so you have something to put in here if you save it here.
Oh, okay.
Yes, yes, yes. Right. What Shadi was saying was that in that last line where you put something into v distance, that's the value that will be taken there on the next iteration. So it goes. So this is the loop, right? And you assign a value to a variable here in the loop, and then go to the top of the loop again. That variable will again have that value, unless we're redeclaring the variable. No, I don't think we're redeclaring the variable. Yeah, right? Because that variable exists from outside of the loop. That value is not going to be refreshed each time. It's just being reset here. Maybe I'm thinking that when we run it once, it'll make a lot more sense, right? If we run it once, you'll actually see the values and see what's happening, and it'll make a lot more sense. Shall we run it and then we can come back to some more questions? Is that okay with you guys?
Yeah. Did you want us to do the prompt ourselves, or?
Yes. Can you do the both of the to-dos? Okay. I will give you 5 minutes, right? I'll take a bio break and I'll come back. And in those 5 minutes, I'd like that. Hopefully not Shadi. Okay. So Shadi should not be the one who's, Shadi, don't do that. Okay. Someone else call out the code, just like I've been calling out the code. Okay. And then Shadi will type. Is that okay? Great. Shadi's okay with that. Is someone else okay to just call out the code? Doesn't matter if it's wrong, okay? There's so many of your classmates around. They'll basically say, no, let's try something else. No, that's wrong, and things like that. People have been correcting me too. And hopefully you'll also get the same kinds of corrections, okay? So, and Changwon is not here. 5 minutes, maybe she'll come back. But can you do that? I need to go and take a bio break, okay? So I'll be back and hopefully finish that.
We couldn't hear you, by the way, Shangwan.
Cannot?
Yeah, I can.
Yeah.
Okay. Anyone want to take a stab at it?
Sure. Just C out type horizontal speed in quotes colon.
Horizontal speed.
And colon space. And then what's it called? Semicolon, and then next line C in speed. Not in quotes, yeah.
Did you say quote? Oh, not in quotes.
Oh,
Okay.
yeah, non-quotes. I think that should be good. Please correct me if I'm wrong.
Can I suggest to print a prompt that is more user-friendly? So
Oh yeah.
Please put in your horizontal speed. Or you can do whatever. I was just suggesting. Go ahead.
Yeah, that's good.
Okay. What do I write? Please put in the or type in horizontals. Ooh, okay.
Okay, I think it's good for that to do.
Yeah.
And then the next one, C out in quotes the horizontal speed typed space. And then or one space, and then left shift and then speed.
Okay. I think we're done. Oh, and this, okay, and we already called that. Okay, dope.
Okay.
Ready?
Mm-hmm.
Great. Okay. All right. So that is correct. We just want to clean it up a bit because the comments are now messed up, what we'll do is take that comment on line 46, because you're doing both the prompt and the reading in the first part, right? So yeah, put it there after 41, and put it on line, yeah, and say on the next line.
Oh, right. Sorry.
Yeah, on the next line, you put it on the, and say and read in. Yeah, and then get rid of the to do, because there's no to do now. You've done it. Yeah.
Oh, I see. Okay.
That one also.
I want to ask something.
Yeah.
Is there supposed to be anything within the parentheses at the int main in this type of function, or is it okay to just leave it blank?
It's okay to leave it blank. Okay. Yeah, it's C++ allows you to do that. You can have a main that is called with no parameters, or a main that is called with parameters. Now, main called with parameters is really strange, because you don't call main, the operating system calls main, right? You only call other functions. So what does it mean when main takes parameters? I'm not going to go into that. We've done videos on this on our channel. And in fact, if I'm not mistaken, I explained this in quest number 2 or 3, right? Limerick, maybe in Limerick, there's a small explanation. It's not core to C++, so let's not waste time on this. This is actually so simple that you will pick up some by yourself, the reason for mains parameters. Okay, so is that okay? We won't talk anymore about that. Okay, I think that's good to go. Is it not good to go? Yeah. All right, let's run it. Let's run it. Yeah, make it even bigger console, because we're going to have a lot of lines there, I think, right? Let's see. Let's make our horizontal speed, I don't know, let's say, we got to pull a number out of thin air here, because let's say 5 meters per second, right? 5 meters. No, let's say 50 meters per second. 50 meters per second. 50.
Just a sec. It's not typing.
Oh, it isn't? What's going on?
I'm like 5.
Oh, because you you have to go to the terminal. Click on terminal. Now do an ls-l. Oh, can you do that? No, I don't know. Yeah. Oh, good.
And then
CD to projectile. Yeah, ls again. Main, you got it. Oh, see, I like VS Code this way, right? It's producing files, the binaries, object files, but it's putting all in the same place. Xcode puts it all. It's not all over the place. You just have to figure out the secret places where it stores it. I like it this way. Right? So you want to run this? No, the name of the program to run is the one in red. Okay, you say /main. Main. Enter. Right. Yeah. Make it bigger. Okay. Right. Say 50.
50.
Whoa. Oh well. Okay. So it did something there, but it printed too many blank lines. So what we want to do is.
Is that even blank lines? What is going on? I don't think these are blank lines, or is it?
Oh, they're not blank lines?
These are all just like blank lines. It didn't do anything.
There's one dot somewhere in the screen.
There's one dot at the end. So what we want to do, I think we need to debug this. Yeah, it's cool. It's cool that we have something that's not working, so we can debug it. And getting the hang of debugging, this is fantastic. So let's go back to our projectile thing and say, after calculating the before this, on line 26, okay, line 26, line 26. Yeah. Say enter there. Yeah, and then say cout.
Did you want it to be in the for loop? In the big for loop?
Yeah, it's in the big for loop. Yes, in the big for loop. Say cout. Left shift. Sorry. Okay, and then you say t equals, and then the value of t. Now you got to say that within quotes. T space equals, and then right, yeah, after that left shift t, and then again more left shift, one more left shift, and then within quotes you say comma space H underscore dist equals space equals, yeah, and then H, yeah, H distance. And then you want to also do the V distance, just like that. And I think H distance, yeah. Yeah, you need a space on the left side of the equals also, just to make it look nicer. Okay, so
Did you want to
that's
see
V
that?
distance.
Oh, yeah.
It should be V distance, and then V distance, and then followed by NL. Oh, you need an equal sign after the V distance. Oh, you do have it. Okay, yeah, great. And then NL after that. All right. Now I want to run it in my head to see. So it's going to print 150. So it has to print 150 of those lines for sure, right? Because it's in the loop and it's just a simple print. So it's got to print 150 of those. So let's run that and say 50 again, like before. Oh, you got to recompile it. You got to recompile it. So
on
there must
terminal.
be an option. You can recompile it here, but just hit the triangle. It'll just do the recompilation, and then you can go to the terminal and run it again.
This is where you want to go, right?
Yeah, up arrow, up arrow. No, up arrow.
Oh, up arrow. Sorry.
Yeah, you're not getting. Oh, no, not caret. Up arrow. You have up arrow?
Oh.
There you go. Yeah, dot slash main. Now hit Control L before you run it. Okay, that's fine. That's, yeah, increase the size. Increase the size. Even more.
I wanted to Control L it before. Did you want me to Control L it or no more? Not anymore.
Oh yeah, Control L it. Control L it. Yeah.
Okay.
You can control it now.
I don't think I can do it right now because it wants me to type in this thing.
Oh, you're inside.
How did you type in your terminal again?
How did I type in? Open your terminal.
Mm-hmm.
And then open this file that we are in, and then put in dot backslash and main, and it will start.
How did you open that file?
How do you open it? Okay, you do CD. Maybe I can I go back, Professor?
Oh, no, I think he's asking, how did you get to your terminal in the first place? But there is a tab.
Yeah, I'm at the terminal. It's CD.
Yeah.
It's not working for me. And then
How do
I see.
Project name or the folder
wait.
name?
Okay, wait.
Yeah, it's inside the project.
Let me do it real quick for you.
Oh, okay.
Thanks.
Code is already running. Okay. New terminal. So you're at this terminal, right? You're at whatever file you do see. First of all, do ls to see what you have, and then our thing is projectile. So I say cd projectile, and then you can
hit the tab key. Yeah. There
you can do pro and then tab, and then we'll go in and then do ls again to see what you have. Main is the thing that you want to be in. So do main, and then it will go to everything.
Say, let's say 50 times 0.01 is 5 already. So it will be 5 spaces, right? So 50 times 0.01 is, what is 50 times 0.01? It's 0.5, right?
Yeah.
So we should say 100 so that for each time it will move by 1. So 100 times 0.01 is 1. So the first time the horizontal distance should be 1. The second iteration, the horizontal distance should be 2. Third line, horizontal distance should be 3. Yes? Okay. So, but each time before printing the line, it's going to print some blank lines before that. And that is determined by, so let's say 100 there. Okay, let's now scroll up and see what the messages were. Okay, so where are the messages that we printed?
I know. I don't know.
Wow. Okay. Now we're all right. Let's do this in the terminal. Up arrow again. Up arrow again. Now space, vertical bar. I think that's shift backslash. I think vertical bar. Yeah. Now do more more. I hope this works. Okay.
What is this?
What this is going to do is that there's a lot of output. Oh, I see. Okay, now just say 100 and hit enter. Okay, the prompt is there. You don't see it. Okay, 100. Type 100 and hit enter.
It's not typing.
No. It's just typing. Hit enter.
Oh, it's just. Oh.
Yeah. Okay. All right. So what it's done is, yeah, we shouldn't have done that because it's confusing to beginners. What happened? if you're interested, is that the first time we ran it, it printed so much blank lines that it wasn't enough for terminal to store. So we can't scroll up. Most of it scrolled out of the even, the virtual window. But we don't want to see, we don't want that to happen. We want to see what's in there. So we say, don't dump it all to the screen, right? Show it to me page by page. So it'll just show the top, and then when you hit space, it'll go to the next. That's what's happened here, okay? So, however, when we did that, everything it printed went into that virtual thing there. So you don't even see the output until it finished everything. That's why the prompt wasn't there. But we had, with experience, I know the prompt isn't there. It's waiting for our input, so we can type the number and hit enter. It'll just run. Okay, so that's what we did. Okay, so now the first one is t equals 1. Oh, your h distance is like crazy. Something is weird here. Okay, why is our h? That's the reason. Okay, why is our h distance so big? So let's go back to our to the place in our function. So where do we calculate h distance? H distance is
here.
Oh yes, I'm so sorry. Okay. Because each one of our horizontal positions is 0.01 seconds, right? It's not 1 second, it's 0.01 seconds, isn't it? So what we should do is t equals 0 to t equals 100. We're not actually calculating, that's not 1 second, it's 0.01 seconds. So our t, the actual t, is 100th of a second. So what we want to do there is in the loop, after I say this out, you can tell me if you understand or you need more explanation. Okay, so on line 18, hit enter. Here, what we're going to do is say void. No, I'm sorry. So they say double. Effective time, actual time. Yes, let's just call it actual time. Okay, actual time, actual underscore time equals t divided by 100.0. T divided by 100.0. Okay, semicolon, and put a comment there saying that our time is measured in 100th of a second. Our time is measured in 100th of a second.
$100 a second.
Yeah, and then the calculations that use t on the next two lines, it should use actual time, not t, right? So it's change the t on the next line to actual time. Okay. Okay. All right. Now, if you compile it and run it, we should probably see better messages. Even if it doesn't work, we'll actually see better messages.
I made a little difference to the, or
you don't have to change anything else. The horizontal speed type. No, that's all fine, I think.
I changed.
Oh, what you want to put?
I wanted to put a space between it or a line between it to make it more readable.
If you want to do that, yeah, I think that's okay. That's fine.
Okay. I think every time, because we have nested loops, we have to stop the code from running every time, or it's going to go on forever.
No, I don't think so. It should just end right there. It should not have that problem. Let's run it now. If it doesn't work, I'll take a closer look at it.
Okay,
right now, I'm just Q. Oh, I see. You have to say Q. You're inside of more. You just need to get out of more. Just say Q. Okay. Now we can do an up arrow. Assuming you have already compiled it, it should be able to. Yeah. All right. If you want to do more, you don't need more this time. I don't think you need more. Get rid of more. Yeah.
Sorry, my computer is being a little slow, so.
Yeah, it's okay. It's okay.
What were we doing again? I forgot. Oh, right. Okay.
Okay. Let's say 100. All right, there you go. All right, now it's starting to look better. Okay. Obviously, there's a scope for making it even better than this. I think go right to the top. Go right to the top. Okay, I think it's starting to look much better now. Now you can go and comment out that thing that we printed, the t equals and so on, right? T equals. Comment it out.
Where?
Yeah, line 28, I think.
Oh, okay.
Yeah, now compile and run it now. Now we'll see it without all that junk, right?
Let me see, how can I open my thing?
There should be an option for VS Code to just compile it and not run it. So build, I think. Is there a build?
Run
Or you
build.
have to create a build task and all for this. I don't know how to do that. Just do a, the
You can
triangle
just
button.
you can just press Control Shift B to build it.
Control Shift B, is it?
Yeah, you can try
Right,
Control
okay.
Shift B.
Okay.
Control Shift B.
And then Control Alt N is to run it.
Control Alt,
And
Control Alt. I don't have an Alt. I have
Oh.
Command.
Oh, no, it says build finish with errors. It says no, build
Oh,
finished with errors.
maybe that's for Windows, not for Mac.
Oh, okay.
What's going on? I see the code and then there's stuff underneath and all. Is this a terminal? It is a terminal. How do I see the code there? Well, how did the code come up on screen?
I have no clue. Maybe it
Go to
was
the end and hit Control L. Clear the screen. Clear the screen. Okay. Now hit the triangle and build it, or Control build so that hotkey that Changwan mentioned.
Oh, okay.
What is it? Control Shift.
But that's for Windows. I'm not sure if it works for Mac.
If we're trying to build
No,
a tab.
Oh yeah, that one also
Okay.
works.
The Command Control and B. Okay. Command Control B.
But no, we haven't built the task. The build task, whatever that build task is.
Oh.
Build task. Or maybe just click that, select that. We'll see if it works. Select run build task. That is really Control Shift B.
Yeah, that's what it does when I do that.
It says terminal process failed. Build. You have an error. So just hit the triangle. It'll actually tell us where it is. Right. If you hit the triangle button, the play button, it'll tell us. It'll take us to the place where the error is.
It says code is already running when I press the run.
Okay, stop it, and run it again. Now compile it. No, you have to compile it. Did you compile it?
Compile? What do you mean?
The triangle button.
No,
Build
I
it,
thought,
yeah. Okay, all right.
did you want me to?
What's going on? Oh, I see.
This is the output now.
Okay.
This is terminal. So let me.
Oh, I see.
Main it real quick.
Oh no, forward slash.
Oh,
Not back.
forward slash, okay.
All right. 100.
It's not typing. Okay.
Okay. All right. Now let's take a look. No, that's it. Yeah, that's where it started. Why is it just like this? It's not printing blank lines for the vertical distance. So, but I think it is correct.
Yeah, I think that's the reason is you use the travel distance to travel. You should use the original version of your code, not using the distance to travel. You just use the v distance.
Oh, did we? Go back?
Yeah, because when t increase, the v distance increased. I mean, if you use v distance to travel, you are using like incremental increase of t. I mean, t increased by 1.
We're using the total. We're using the total time since.
I think if you change back to v distance, not v distance to travel, it might look more like a curve.
I'm not sure. I don't know if that is correct. I don't think that's correct, Changwan, because
think like when t is 1, then 1 is 0.5, right? 1, then when t is 2, the y that the v distance will be 2, and then
yes.
But if you use the incremental, like if you use distance to travel, then the horizontal or the vertical will be 2 minus 0.5. It's still
that's what we want it to be. Right?
Yeah, but it still starts from the 0. You
I'm
maybe
not
just to try it to just maybe just Just change
All right,
the,
do what? Yeah, just to convince. Yeah, just to do the change that Changwon is recommending, and we run it, and then hopefully everybody's mind will be at ease. So what is the change, Changwon? We want to change line
just
30.
try. I'm not sure. Just try it. Try change v distance to travel back to v distance. In line 30.
This,
Yeah. That's it. And then just try again and see. I'm not sure actually.
do I have to?
I don't think that should work. If it works, I'll be surprised. Run it. Has it compiled?
No, yes, it has, but like I have to do this every time.
I think you have to recompile it.
Enter.
I did press run.
But that's not compiled based on the new code. Right?
Okay. I'll do it again. Okay.
I think it is compiled, right? Based on the new code. Did you press the triangle button?
Yes, I did press that triangle.
Yeah, then I think it would have compiled.
I can try it again, but just like I keep on closing or like bringing the terminal too far
Stop
down.
it, yeah,
I can't find it. Okay. So here's it. Here it is compiling again. Then we are gonna main it and say 100.
Oh, I see. Well, we're actually starting to see the parabolic shape, but I'm still not convinced that this is the right thing to do, because what we need is the differential distance, not the total distance from the top. Why? How? But it is in fact working here. How is it working? So maybe I was wrong in my thinking. I can't even imagine why that would be the case. Run it one more time, and let's give it a smaller vertical, horizontal velocity. Let's say 50 this time. Let's say 50.
Just a sec.
Okay, but it's starting to look like a parabola, but I am still not convinced why the change that Changwon suggested works, which could potentially mean that you're right, and I'm overlooking something so simple, and the bug could be on my end. But I want to think more about this, Changwon. Why is the differential distance not working? Why? Because you see, when you calculate the distance, it is the distance.
You need
Here, so here's let me explain my thinking. So I'll explain my thinking, and you can tell me whether I'm right or wrong. Okay. All right. So oh, you can't see my cursor. Let's look at the star in the middle, right? Not the top one, not somewhere. Yeah, right there. Now, when that star is printed, the position of the star reflects the distance already covered vertical from there to here. Yes. So the next star that you're going to print should be printed after covering just the incremental distance.
Yeah, but the t you used is not T1 T2 minus T1. It's T2, not T1 T2 minus T1.
Oh, you're saying I'm using I'm not using the differential time. I'm using the total time.
Yeah, you're using the total time. Yeah, you're not using the.
I'm using the total time, but not the differential time.
Yeah.
But still, yeah, okay. Even though I'm using the total time, I get the total distance travel. If I use the total time, I get the total distance travel. Yes or no?
Yes, you should use the total distance if you are using the total time.
Right. So I will get the total distance travel. So,
yeah.
So which means that bullet should be total distance travel from the top.
Yes.
So if I want to print bullet total distance from the top, the previous line already printed up to here. So I just need to go.
Yeah, but if you go from the previous line from this line, you should use the t. You should use the differential t. But now you're using the total t, so you should using the total distance.
Okay. I should think more about this clearly, because the difference here between what we're saying is that I'm calculating half times g times total distance t squared, right? The total time, give me the total distance. And so I'm calculating that position, and I'm saying that, I'm printing a whole lot of lines. I'm already that far from the top. I just need to go a little bit more. That's what I'm calculating.
Yeah, but when you
And,
calculate the v distance, you are using the t.
oh, where is v distance? Yeah, so that v distance there is that v distance, what I calculate there, what is that distance? Is that the distance from the first line or is it the distance from the previous line?
It's from the first line.
Yes, okay, right? So if it's the distance from the first line, then I just need to find out what the difference is from the previous line to here. Yes? Yes or no? Anyway, that's how it's playing out in my head. Okay, so if it's playing out differently in any of your heads, okay, you should please feel free to correct my misunderstanding, or doesn't have to be here. You can also correct it in the forums and say, hey, this lecture, you can look at this lecture, and this is the discussion that that Shangwen and the professor had, or maybe Shangwen said I and professor and I had, and this is my reasoning, and this is why it should be. This is why this is the right way to do it. This is why this is the right way to do it. And everybody, including me, will be so grateful for that, because I cannot see why my approach should be wrong. Let's put it back to my approach. I want to try something. Okay, can you put it back to my approach and say, get it to, get it to a v distance to travel, right? It should be v distance to travel. Travel. I think we just need to play with the velocity here. The velocity, try now, compile and run it now, and let's say give it 10 meters per second. Okay, 10 meters per second. Yeah, I'm thinking maybe it's just an issue of the scale, or 10 meters per second. All right, so now let's try 20 meters per second. Okay, 20 meters per second. Okay, and now let's try 50. Okay. All right. I think that is the correct parabola. It doesn't look like a parabola. It looks like a straight line, but I think it is actually a parabola. And it's just that how can we make it 100? Make it 100. I think it'll look more like a parabola. Make it 100.
I made it 150, and this is.
Oh, you made it 150. It still looks like a straight line. No, yeah, it looks like a straight line with 150. Okay, all right. Anyway, I think this is a very good start, and we've actually got the only thing we're trying to figure out here is what the right thing to do is. It would be fantastic, and I'm going to think about it too, right? If Shadi will share this code, we can talk about this code for a little bit more. If you share this code, I'm going to think about this more. Now that we have some code, I can think about it, right? And I will weigh in the forums, and if you share the code and also ask the question, what should we do, right? Why does the trajectory look linear rather than a parabola? It should look like a parabola. Now, it should look like a parabola if it actually covers a lot of vertical distance early on, and that's not happening. It's traveling. Yeah, okay, maybe that's the reason. So what after squared?
Professor,
I think about it. Let's not waste time. Yeah, to me, it looks like we're doing the right thing. Okay, I don't know if Shangwen's argument was convincing, but I'm not 100% sure it is correct. Not convincing. It is a good argument, but I don't think it is right. But it is worthy of thinking more about. I am certainly going to think more about it because what I suggested didn't seem wrong to me. So if there is something wrong, I would be so overjoyed to find it. Right? Like every scientist, they're happy when someone disproves their theory because they said, I tried so hard to disprove it and someone did it finally. Okay, so they're actually happy when something like that happens. So I'll be happy to see if there is a problem with this. I can't see any glaring problems, and I just need to think more about it. In terms of if it's shot with a high velocity, maybe it'll cover more distance initially, and then I think that's how it should be. I don't want to waste class time thinking about this, and also I don't want to rob the thinking from you, right? I want each of you to think about this at the same time as I am after class, and come up with your own theories as to what is going on and how to fix it. What we need is a nice parabola shape. Okay, see if you can somehow do it figure out what the issue is and try and fix this problem so that when you run it with, at some decent velocity, it doesn't have to be 50 or 100. You say, I ran it and I gave it this velocity, and now you can see this nice parabola shape, right? It's got to look like this. Everybody knows, right? In your mind, you can imagine what it'll look like. Yes, it should be like a parabola. It shouldn't be like a straight line like this. It should be like a parabola. Sometimes it may be that it looks like a straight line because things are changing so fast that we didn't actually plot many points in this curved part, and lots of the points we're plotting are in this part of the parabola, which looks more like a straight line. Yeah, then it may look like a straight line. So that means what we need to do is essentially just increase the granularity so that we print a lot more up there where it's curved. Well, obviously curved. It's curved everywhere, but at the top it's more obviously curved. So we need to print a lot more points there. And in order to do that, how do we print a lot more points out there? Oh yeah, I think we can do it this way. Okay. So vertical distance to travel 0.5 half GT squared.
Sorry,
yeah, go ahead.
But I have to hop on to my next class. Did you want me to share?
Oh, is it? What time is it? What time is it? Oh my gosh. You know what? I just keep losing track of time like this. Thank you so much. Thank you so much, Chadi. Right? Yeah. I thought we were at like 9:30 or something.
Yeah, no, 10:12.
Oh wow! And you guys are still here. I'm so grateful. I'm so grateful, Shadi, especially since you have another class and all. Thank you so much, and thanks for being patient with me, Changwen. Thank you so much for bringing up an interesting point. The thing I would love even more is one of you with me can think about this, try it out, and print something in the forums. Okay, share it in the forum saying I got this picture, right? The screenshot of this parabola, and this was a problem or there's no problem. Okay, thank you so much. Did you guys get something useful out of this, right? In this class, right?
Yeah.
So loops. This is how you do loops. Read more about loops. You only need to know one loop, solid, right? For loop. Get solid on while loops. For for loops, and then you can figure out how while, do while, all of those things work. But you only need one to do all of the things. Okay. So in fact, we'll try and do everything from now on just using for loops as much as possible. Okay. Only use other kinds of loops where absolutely necessary. So thank you all so much. I will see you on Thursday, hopefully. Yeah. All right.
Yeah.
Thank you all.
Professor?
Yeah.
Professor, I want to ask.
I'm going to stick around. People can go, right? Yeah.
I want to ask, what is the exact midterm date? So, because I want to complete quests 1 through
Thursday.
5.
Week 6 Thursday.
Week 6 Thursday. So, okay, week 6 Thursday, and I want to make sure because I want to complete quests 1 through 5 to take the data representation. Yeah.
Yes,
yeah. No,
yes,
still having
totally.
a bit of trouble with quest 2 right now, but I think I'm slowly getting the hang of it. But thank you.
This is week 3, and if you're already on week, quest number 3. And you completed quest number 3, don't go to 4 and 5 already. Just do data representation, then go to 4 and 5.
Quick question.
Oh, I see. I'm sorry. Yeah. Go ahead, Chadi.
If I were to share the code, would I share it on Reddit?
Actually, no. It's a pain to share it on Reddit. Here's what you can do: share it on onlinegdb.com or cpp.sh.com, codingrooms.com, and they will give you a share URL.
Okay.
And you can share the share URL.
Would GitHub work?
GitHub is fine.
Okay.
Put it on GitHub. If you have a GitHub account, all we need is for students to just click on a link and go to your code.
Okay, got it.
Yeah.
Okay. Thank you so much.
Yeah.
Jaden, you're good.
See you
Yeah.
Thursday.
Jaden, you're good. Okay. Since you're making progress steadily like this, whenever you're ready to take the data rep quiz, just let me know. I'll open it. You don't have to wait until 5.
I don't have to wait until taking quest 1.
Yeah, because I put it there only to make sure that students are serious, and I can see that you're serious about learning. Okay,
Yeah,
so whenever you're ready, you can do it.
Yeah, sorry, I haven't turned in quest 2 yet to the process. I like to make sure I do everything before I want to make sure I check it in.
Perfect.
Thank you.
Yeah, that's the way to make progress, really, right? So I
Yeah.
think you're doing everything right.
Yeah,
So don't
bit
worry.
stuck on quest
Okay?
2, but I think still stuck on.
You'll get
quest
over
2,
it. You'll
but
get over it.
making
It's just a matter of time. It's just a matter of time. I'll open up the data rep quiz anytime you want.
Thank you. Goodbye.
All right, no worries. Thank you, Shangwan. Thank you, Juan. Anthony, this is your first class. Anthony, this is your first class I'm seeing you here.
Yes, it is. I was
All right.
just.
You got to make it to every class, okay?
Yeah, no.
Can you make it to every class?
Yeah, no.
You don't have any conflicts, right? Nope.
Just the last couple of times I didn't, because I was in between doing work and trying to get things situated. So now that I've gotten things more situated with my work schedule and everything, I should be fine making it to the classes now.
Fantastic. Attend every class, and any difficulties or questions, please feel free to ask in the subreddit before even going to the STEM Center, because there are other students, even though you are just starting, there are other students who've been in class, but they've had other challenges, okay? And they may still be facing the same problems that you are. So please ask in the subreddit. Your classmates and I and the tutors will jump in and help you, okay? At the end of the day, the important thing is just stick around. If you're on the bus, you'll get to the terminus, right? People who hop off the bus never get to the end. So please stay on the bus and we'll make sure you get there.
Yeah, not a problem.
All right.
I appreciate it a
Thank
lot.
you. No worries, no worries. Thanks. All right, see you on Thursday.
Yeah, see you Thursday.
Bye.